Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. Hello everyone, welcome back to my channel. So today we'll be solving paper 1A of time zone 2 SL. Let's get started with the first question. So a test tube contains a mixture of liquid hydrocarbon. We have to identify what is the type of mixture and how can we separate this. So if you have two liquid hydrocarbons, right, what happens is they are both nonpolar, right, because they are hydrocarbons, so they will be miscible, right? So they will completely mix with each other. When two liquids completely mix with each other, it forms a homogeneous substance or homogeneous mixture. Yeah. So type of mixture will be homogeneous. Now, how do we separate homogeneous mixtures? Now, if you look at the methods of separation, you have filtration and distillation. Now, obviously, the answer is distillation because if you have distillation, you can remove the liquid hydrocarbons based on their boiling points, right? But why will filtration not work in this case? Because filtration is used to remove a solid from a liquid. If you have sand and water, you can use the method of filtration to remove the sand from water, right? But if you have a homogeneous mixture, you have to use distillation. Okay. Next, which property is same for the water containing tritium and water containing hydrogen? So tritium and hydrogen, the main difference between the isotopes is the mass. Tritium has a mass of 3 and hydrogen has a mass of 1. So any property which is related to the mass will change, right? But any property which is related to the reactivity or related to electrons and stuff, they will remain unchanged. Now density is dependent upon mass, so density will change. Dipole moment is dependent upon the charges, right? So in tritium and hydrogen, you have the same number of proton and electrons. So dipole moment will be the same. Yeah, or basically here, H2 or tritium 2, right, or T2, both are non-polar molecules, right? Because they are symmetric. So you can also say that the dipole moment will be zero in both of them, right? Boiling points will be different because boiling point is a function of mass. Bigger mass will mean that the London forces are stronger, right? As a result, boiling points are higher. So tritium will have a higher boiling point compared to water. And the relative molecular mass, obviously, it will be different because for tritium, H2 would be like 6. For normal hydrogen, H2 would be 2. So answer would be option B. Next, the emission spectrum of hydrogen provides evidence for which feature of atomic structure? Now, if you're looking into emission spectrum, right? Emission spectrum is basically the analysis of the photons released by electrons when they return to their initial shell, right? So excited electrons returns back to their initial or lower shells after emitting the energy absorbed as a photon. Right? And when all of these photons are collected, right, you get the emission spectrum. So it's mainly like, the entire emission spectrum is based on electrons itself. Now, if you look into the option, it's not definitely not related to the nucleus, definitely related to the energy levels because electrons, return back to lower energy levels. Like the excited electrons generally are at higher energy levels, right? So when they return to the lower energy level, they will release the photon. So obviously, energy levels are related. Isotopes, no. Protons, no. So answer would be B. Question 4. What's the maximum number of electrons that can occupy n equals 3? So maximum number of electrons is given by the formula 2n squared. So just replace n with 3, you will get this, so which gives you 18. Option C. Next, we have to find the empirical formula of a compound with the following composition by mass. So we'll assume that the total mass of the compound is 100 grams, right? So mass of carbon is 37.5 grams, hydrogen is 12.5 grams, oxygen is 50 grams, right? So moles of carbon will be 37.5 divided by 12, which is 3.125. Moles of hydrogen, this will be 12.5 divided by 1, 12.5 again. Moles of oxygen will be 50 divided by 16 gives you 3.125. Now we have to take the simplest whole number ratio between moles of carbon, moles of hydrogen, moles of oxygen. 3.125 is to 12.5 is to 3.125 again. Now we'll divide all these three numbers with the smallest number, which is 3.125, right? So when you divide everything with 3.125, you'll get 1 is to 4 is to 1. So your empirical formula will be CH4O, which is option D. Next. What is the charge of the monoatomic ion usually formed by the element with the following electronic configuration? 2s to 2p3 is the electronic configuration of nitrogen, right? So it has 5 electrons in the valence shell and it needs 3 more electrons to, complete its octet. So nitrogen has two options. Either it can lose 5 electrons or gain 3 electrons. In this case, obviously, nitrogen is a non-metal. So it's easier for nitrogen to gain 3 electrons. So nitrogen will gain 3 electrons to form N3 minus. N3 minus has a complete octet, right? So it's stable. So charge on N3 minus is -3, which is option A. Next, which molecule is polar? Now for polarity, I generally suggest like two easy tricks. First, we have to check whether there are lone pairs on the central atom or not, right? If there is a lone pair, then obviously that's polar. If there are no lone pairs on the central atom, we just have to check the symmetry of the molecule, right? For example, in CH4, CH4 is completely symmetric about the carbon atom, right? So this is non-polar. Similarly, C6H6 is benzene. Benzene is also pretty much symmetric. Yeah, it has like 3 lines of symmetry. Okay, so benzene is also nonpolar. But if you look at SO2, SO2 looks like this. If you draw the Lewis structure or the structure from Vesper. Yeah. As sulfur has lone pair on the central atom, this dipole moment will be much higher as compared to these. So as a result, there's a net dipole moment in this molecule and SO2 is polar. CO2 will also be nonpolar because it's a linear molecule, right? So dipole moments will get cancelled out on both sides and that will make it nonpolar. Next, we define the retardation factor according to the paper chromatogram. So retardation factor is like length moved by the compound X. So here length moved by compound X is 21 divided by length moved by solvent. Solvent is this much. So this length is 21 plus 7, 28. So 21 divided by 28 gives you 3/4, right? Which is 0.75. Option B. Next, we have to identify which metal has the strongest bonding. So here all of them are metals. So we have to identify which one has the strongest metallic bonding. For metallic bonding, you need to check two things, right? Which one has the largest charge, okay? And which one has the smallest size. Now, if you carefully observe these elements, all these elements belong to group 2, right? As all of them belongs to group 2, everyone will have a +2 charge. So, um, yeah, every element will have the same charge, +2, Mg2 plus, calcium 2 plus, Sr2 plus, Ba2 plus. You have to look for the smallest size. Now, if you compare between Mg2 plus, Ca2 plus, Sr2 plus, and Ba2 plus, obviously Mg2 plus will have the smallest size because as you move down a group, your atomic size or ionic size increases, right? Smallest size occurs at Mg2 plus, so Mg2 plus will have the strongest bonding, strongest metallic bonding. Yeah, the answer is A. Next, which monomer produces this addition polymer? So if form the monomer, to form monomer, you cancel these two bonds and prepare a double bond, right? Your monomer looks like this. Now check which compound is this thing. So there is 3 carbon atoms, right? This one has 4 carbon atoms, so ignore. This one also has 4 carbon atoms, reject. This one has 3 carbon atoms, so this possibly can be the answer. Yeah, this is the answer. If you see CH3 here, hydrogen here, hydrogen, hydrogen. So one carbon has two hydrogens, the other carbon has a CH3 and hydrogen. The answer should be C. D is incorrect because D has four carbon atoms. Next, which label shows the D block elements in the periodic table? This is S block. The middle ones are D block. On the right side, you have P block. C is not the answer. But yeah, this is P block, and bottom you have F block. So answer would be B for question 11. For question 12, why do group 7 elements have higher first ionization energy than group 1 elements in the same period? Right. The thing is, higher ionization energy means your electrons are more strongly attracted by the nucleus. Now, if you look at the option, the first one can be eliminated. If you have more electrons in valence shell, then your ionization energy should be less because more electrons will produce a lot of repulsive force, right? So this is obviously not the logic why group 70s have higher ionization, higher first ionization energy. If this one was true, your question would have been why it has a lower first ionization energy, because more electrons will reduce the ionization energy because of repulsion. Next, group 17 elements have more filled energy levels. Again, if you have more filled energy levels, yeah, it's not that technically, right? Even if you have more filled energy levels, what happens is your repulsion will be higher. So, and also reject this thing. Group 17 elements have more paired electrons. Again, not a good logic. But the last one is correct. They have more protons. As group 17 elements have more protons in the nucleus, what happens is the electrons in the outer shell will be attracted more strongly. So you would need more energy to remove an electron from group 17 compared to group 1. Yeah. And basically for part option B, if group 17 and group 1 elements are in the same period, they will have the same fully filled energy levels. Okay. Now, question 13. What is the oxidation state of nitrogen in N2O4? We'll take the oxidation state of nitrogen as X. So 2 nitrogen will make it 2X, 4 times oxygen. Oxidation state of oxygen generally is -2. So 2X minus 8 becomes 0. So 2X is 8. So X is +4. Option D. Next, which compound is an isomer of propanone? So this is propanone, a ketone. So isomers of ketones are generally aldehydes. So let's check. So this one has 3 carbon atoms, 1 oxygen, and 6 hydrogen. Let's check the options one by one. This one has 4 carbons. Obviously, this is not an isomer. This one has 3 carbons, 1 oxygen, but number of hydrogens is 8. Again, not an isomer. This one, 3 carbons, good. 1 oxygen, good. But 1, 2, 3, 4, 5, 6, 7, 8, 8 hydrogens. Not an isomer. But if you check the last one, you have 3 carbons, 1 oxygen, and 6 hydrogens. So this is your answer. Answer would be option D. And option D is an aldehyde. So yeah, makes sense. Next, what is the correct interpretation of this energy profile? Reactants have lower energy as compared to products, so reactants are more stable, right? Now, reactants will absorb energy from the surroundings to form the products, right? So, absorbed from the surroundings. So, if energy is absorbed from the surroundings, your surroundings will become cooler and the temperature decreases. The temperature would be decreases and reactants more stable than products. Answer is A. Now, moving on to this question 16, you define the enthalpy of combustion from this calorimetry setup, right? The amount of fuel is given, so you know the moles of fuel burnt, you know the mass of water, you know the initial temperature, you know the final temperature, you know C, right? So first we'll find how much heat was absorbed by water, which is mc delta T, right? Mass is 200, C is 4.18, delta T would be final temperature minus initial temperature, right? We could take mass in grams because the unit of C is also in grams, right? So if it was kilograms, mass also had to be converted to kilograms. Now, if you feed it in a calculator, you'll get 3344 joules. That is the heat absorbed by water. Now, enthalpy of combustion for calorimetry is given by this expression negative Q over M. So negative 3344 divided by 0.11. It will give you negative 30,400 joules per mole. Divided by 1000, it will get minus 30.4 kilojoules per mole. Right? So that is option B. Next, what is the coefficient of oxygen when equation of the complete combustion of ethanol is balanced using smallest whole numbers? Now let's balance it. You have C2H5OH. You place a 2 in front of carbon. This balances carbon atom. Place a 3 in front of H2O, balances the number of hydrogen atoms. Now you have 2 carbons on both sides, 6 hydrogens on both sides. Number of oxygen on the right side is 7. On the left side, you have 1 oxygen here. So you need to balance 6 oxygens on O2. So you just place a 3 in front of it. So this is your fully balanced reaction. So coefficient of oxygen is 3. So answer is C. Next, we have to find the limiting reactant and theoretical yield of hydrogen when 0.2 moles of Mg reacts with 0.2 moles of HCl. Now, to find the limiting reactant, we'll use the moles over stoichiometry coefficient ratio. So, moles over stoichiometry coefficient for Mg would be 0.2 divided by 1 because 0.2 is the moles of Mg, stoichiometry coefficient is 1. Then moles over stoichiometry coefficient for HCl will be 0.2, that's the moles of HCl, divided by 2, because that's the stoichiometry coefficient of HCl, 0.1. The one with the smaller N over SE ratio will be a limiting reactant. So HCl is the limiting reactant. I can eliminate option A and B. Now we need to find the moles of H2. We can use the molar ratio. Moles of H2 over moles of HCl would be 1:2. Yeah. So moles of H2 divided by 0.2 is 1:2. Moles of H2 would be 0.2 over 2 gives you 0.1. Answer would be option D. Next, we have to find the units for rate of reaction. So rate of reaction, you can use this formula, change in concentration over change in time. Unit of concentration is mole per dm cubed. Unit of time is seconds. So mole dm to the power minus 3, s to the power minus 1. This is the general rate of unit which is used in our curriculum. But here, instead of seconds, if your reaction is slow, you can make it hours, right? So if you make it hours, it exactly matches with option C. Why are the rest of the options not correct? Option A is incorrect because volume is missing. Option B is incorrect because moles is missing. Option D is incorrect because seconds or time is in the numerator, it has to be in the denominator. So answer is option C. Next, which changes increase the rate of reaction? Yes, if you introduce a catalyst, obviously the reaction rate increases because catalyst decreases activation energy. Next, increasing the concentration of H2. That is also correct because if you increase the concentration of H2, there will be more collisions or more effective collisions per unit time. That's why the reaction will speed up, will become faster. But if you increase pressure, there will be no change in this reaction because there are no gaseous reactants. Okay. If you increase pressure and if you have gaseous reactants, what happens is all the gas molecules will come close, right? As a result, the number of collisions per unit time will increase and also the number of effective collisions would increase. But in this case, as you don't have any gaseous reactants, there will be no change in the rate of reaction if you alter the pressure, right? The answer would be A, 1 and 2 only. Next, why does rate of reaction increase with temperature? Yes, so rate of reaction increases with temperature because a higher proportion of collisions have sufficient energy. Answer is option B. C is incorrect because activation energy is not dependent with temperature. Activation energy can only be changed by a catalyst. And option A, a higher proportion of collision will have proper orientation. A temperature cannot, change this factor. It's by luck whether collisions will have proper orientation or not. Next, we have to find the value of equilibrium constant for the reverse reaction. For the reverse reaction, equilibrium constant will be 1 over the equilibrium constant of the forward reaction. So 1 over 4.3, option C. Next, what is the effect of doubling the pressure on equilibrium? will keep all other conditions unchanged. So in this reaction, you have 3 moles of gas on the reactant side, 2 moles on the product side. More moles of gas means higher pressure, less moles of gas means lower pressure. Now, doubling the pressure means we are increasing the pressure. Yeah. So this is our change. So equilibrium will try to decrease pressure. So equilibrium tries to decrease pressure by shifting to the side with less moles of gas. Because less moles of gas means less pressure. So equilibrium will shift to the product side or to the right. So either answer will be A or C. Effect of equilibrium constant K, there will be no change because equilibrium constant only changes with change in temperature. We are not changing temperature here, so equilibrium constant remains unchanged. Next, what is required to convert a base into conjugate acid? So base plus H plus gives you conjugate acid. Now, H plus is not a negative charge, it is not a hydrogen atom, it is not an electron pair, but H plus is actually a single proton. A hydrogen atom has 1 proton and 1 electron. If you remove the electron, you get H plus ion, and at that time, you're just left with 1 single proton. Next, which solution has a pH of 9? pH is 9, right? So POH will be 14 minus pH, so pH is 5. So OH minus ion concentration should be 10 to the power minus 5. Now A and B can be straight rejected because the base concentration is very low. Between C and D, C can be rejected because NH3 is a weak base. So not 100% of NH3 will form like 10 to the power minus 5 OH minus, maybe like 5 or 6% will form. But NaOH, option D, is a strong base. So 100% NaOH will dissociate to form 10 to the power minus 5 mole per dm cube OH minus. Answer would be option D. Okay. This one is a weak base, and these two will have lower concentrations. Next, what is the main reason why sulfuric acid has a lower pH than methanoic acid? Lower pH would mean it's a stronger acid, which means higher H plus concentration, which means there is more dissociation. Fine. So sulfuric acid diprotic doesn't really matter. You can also think about H3PO4, phosphoric acid. It has three, like it is triprotic, but still it's a weaker acid compared to H2SO4, right? Option B is correct. Sulfuric acid ionizes more. That's why it produces more H plus, right? Option C is incorrect. If sulfuric acid is a stronger acid, its base will be weaker than the conjugate base of methanoic acid. And lastly, sulfuric acid is soluble in water than methanoic acid. There is no reason for option D because if you have polar solvents, they will also be soluble in water, right? But yeah, they won't be acidic. So answer is option B. Next, in which compound sulfur has an oxidation state of +4? So take sulfur as X. So here X plus 2 times 1 is 0. X plus 2 is 0. X is equal to -2, right? Next, take this as X. X plus 3 times -2 is 0. X minus 6 is 0. X is equal to 6. Again incorrect. H2SO4, 2 times 1 plus X plus 3 times -2 equals 0. 2 plus X minus 6 is 0. X minus 4 would be 0. X is equal to +4. So answer is option C. We'll also test the last one. 2 times 1 plus X plus 3 times -4 is 0. I mean 3 times -2 is 0. Then 2 plus X minus 6 would be, oh sorry, it's 4 times -2. It becomes -8. So X minus 6 is 0, X is +6. So all sulfur has an oxidation state of +4 in option C. Yeah. So magnesium displaces silver from aqueous silver nitrate. So Mg plus twice Ag plus gives you Ag twice Ag plus Mg2 plus. Right? There's a displacement reaction. And this is a spontaneous reaction, right? So we will exactly use this reaction in our voltaic cell. Fine. So we have to describe the silver electrode. Now, if you look into the silver, I mean the half reaction involving silver, Ag plus 2Ag, this is a reduction reaction. Okay. Reduction occurs at cathode. Oxidation occurs at anode. Okay. So this thing is a cathode. Eliminate option B and D. Now, what's the sign on a cathode? So Ag plus accepts an electron to form Ag, right? And Mg2 plus releases electrons in this thing. So this thing will be highly negatively charged because there is a lot of electrons deposited on the Mg electrode by like when Mg2 plus is being formed, right? This electron will be attracted towards Ag because this solution will keep forming Ag plus. So this is a positive solution, right? So this electrode will also be positively charged. Answer will be option A. Next one, which change represents oxidation of a functional group? So if you look at the basic oxidation step, alcohol to aldehyde to carboxylic acid. This flow is oxidation, okay? And the reverse direction is reduction. So here, carboxylic acid is getting converted to aldehyde. This is reduction, not oxidation. Aldehyde to carboxylic acid. Yes, this is oxidation. Alkyne to alkene. This is addition of hydrogen. Addition of hydrogen is reduction. So C is incorrect. And the last one. This is aldehyde to alcohol. Again, reduction. Answer is option B. Now the last question. Which equation represents propagation in a free radical substitution reaction? Okay. So if you look into a free radical substitution reaction, the initiation step looks like this. So Cl2 will absorb sunlight to form two chlorine free radicals, right? So C can be eliminated because that's the initiation step. Another way of identifying initiation step is like if you have more free radicals on the product side as compared to the reactant side, then that's an initiation step. Then propagation. In a propagation step, basically, number of free radicals on both sides will be equal. Yeah. So what really happens is this Cl free radical which is produced will attack a methane molecule to form methyl free radical, and it will snatch away a hydrogen to form HCl, right? This methyl free radical will again react with Cl2. It will snatch a Cl to form CH3Cl and form a chlorine free radical. Now, if you check the first propagation step, exactly matches with option A. So A is a propagation step. Now, why B and D are rejected? So B is a termination step because you see you have more free radicals on the reactant side as compared to product. So free radicals are getting used up. Reaction is coming to an end. Now, why D is incorrect? So D is one of those things where you have like a multi-substituted alkene, right? Disubstituted alkene. So the reaction is kind of wrong. So chlorine free radical will attack CH3Cl and it will snatch away a hydrogen. So the free radical which will be formed is CH2Cl free radical. So hydrogen free radical is not formed. That's why D is incorrect. Now with this, we are done with this paper. Thank you so much for watching this video, and I'll see you guys in the next one. Bye-bye.